Dear students of grade 3 secondary, welcome to our method program. Today we have calculus, general revision. Now with the first example. If y equal sine x to the power n plus 1, then dy dx equals n plus 1 between two brackets multiply sine x power n equals n plus 1 between two brackets multiply y multiply cotan x, n plus 1 between two brackets multiply sine x to the power n plus 1 multiply cosine x, or equal n plus 1 between two brackets multiply y multiply tan x. Now we have y equal sine x to the power n plus 1. Then dy dx equals n plus 1, which is the power of the function sine x, multiply sine x all to the power n plus 1 minus 1, which equals n, multiply the derivative of the function inside the bracket. The derivative of sine x is cosine x. Then dy dx equals between two bracket n plus 1 multiply sine x power n multiply cosine x. Now dy dx equals n plus 1 between two bracket multiply y over sine x multiply cosine x, y over sine x, which is sine x power n. Then dy dx equals between two bracket n plus 1 multiply y multiply cotan x. Then if y equals sine x all to the power n plus 1, then dy dx equals n plus 1 multiply y multiply cotan x. Another example. If y equals e to the power ax, find the value of a which verifies that d2y dx squared minus 2 dy dx plus y equal 0. Then a equals negative 2, negative 1, 1, 2. Y equals e to the power ax. Then dy dx equals the derivative of the function e to the power ax is e to the power ax multiply the derivative of the power, multiply ax equals a. Then dy dx equals a multiply e to the power ax. Now what is the second derivative? The second derivative d2y dx squared equals a multiply e to the power ax multiply the derivative of the power. Then a multiply a equals a to the power 2 multiply e to the power ax. Now d2y dx squared minus 2 dy dx plus y equals 0. Then a power 2 e power ax minus 2 multiply a e power ax plus e to the power ax equal 0. We can take e to the power ax as a highest common factor. Then e to the power ax multiply between two bracket a power 2 0. Then a power 2 minus 2a plus 1 equals 0, where e to the power ax doesn't equal 0. A power 2 minus 2a plus 1 equals 0 is a perfect square. This expression is a perfect square. We can write this expression as a minus 1 all to the power 2 equal 0. Then a equals 1. Another example. The greatest value of the expression sine x plus root 3 cosine x at x equals, where x belongs to open interval 0 and 2 pi. The greatest value when x equals pi over 2 or pi over 3, pi over 4 or pi over 6. Now we have y equal sine x plus root 3 cosine x. The first derivative of this expression, dy dx, equals derivative of sine x is cosine x plus root 3 multiply the derivative of cosine x. Derivative of cosine x is negative sine x, then dy dx equals cosine x minus root 3 sine x. Now dy dx equals 0, or cosine x minus root 3 sine x equals 0, then tan x equals 1 over root 3. When tan x equal 1 over root 3, then x equals pi over 6 or 7 pi over 6. Now what is the second derivative? The second derivative, d2y dx squared equals negative sine x minus root 3 cosine x. Now at x equal pi over 6, then d2y dx squared equals negative sine pi over 6 minus root 3 cosine pi over 6. Negative sine pi over 6 minus root 3 cosine pi over 6 equals negative 2. Negative 2 smaller than 0. Then the second derivative is negative at x equals pi over 6. Then the function has local maximum value at x equals pi over 6. Now at x equals 7 pi over 6, then the second derivative d2y dx squared equals negative sine 7 pi over 6 minus root 3 cosine 7 pi over 6, which equals positive 2. Positive 2 bigger than 0. Then the function has local minimum value at x equals 7 pi over 6. Now the greatest value of the expression at x equals pi over 6, letter D. Another example, integration 1 over x minus 1 from e to the power 3 dx equals the definite integral equals ln e minus 1 equal ln e power 2 plus e plus 1 equals ln e power 2 plus e, or equal ln e to the power 3 minus 1. We have definite integral 1 over x minus 1 from e to e power 3. Now we have quotient 1 over x minus 1. The numerator 1 is the derivative of the function in denominator. Then the integration equal ln absolute x minus 1 from e to the power 3. Now we can substitute ln e power 3 minus 1 minus ln e minus 1. Ln absolute e power 3 minus 1 minus ln absolute e minus 1 equals ln absolute e to the power 3 minus 1 over absolute e minus 1 from the properties of logarithm. Now we can factorize e to the power 3 minus 1 as a difference between two cubes. Then ln e minus 1 absolute e minus 1 multiply absolute e power 2 plus e plus 1 all over absolute e minus 1. We can cancel absolute e minus 1 from the numerator and denominator. Then the integration equals ln e to the power 2 plus e plus 1, letter B. Another example, The tangent to the curve of the function y equals cubic root of x at x equal 0 is parallel to x-axis, y-axis, the straight line y equals x, or parallel to y plus x equal 0. Now we have the function y equals cubic root of x, then y equals x to the power third. We can write this function as this form to simplify the form of the function. Then dy dx equals third multiply x to the power -2 over 3, or dy dx equals 1 over 3 multiply cubic root of x to the power 2. Dear student, this function dy dx has a domain x belongs to r except 0. Then dy dx at x equals 0 equals 1 over 0 undefined. The slope of the tangent equals 1 over 0 or undefined. Then the tangent parallel to y-axis and makes a right angle with the positive direction of x-axis, or the tangent is a vertical line. Then we can choose letter B. Another example. If the curve y equals between two brackets 5x minus a all to the power 3 plus 2 has an inflection point at x equals 4, then a equals 20, -20, 5, or a equals 4. Now y equals between two brackets 5x minus a all to the power 3 plus 2. The first derivative dy dx equals the derivative of the bracket 3 multiply the bracket 5x minus a all to the power 2 multiply 5. 5 is the derivative of the function inside the bracket. Then dy dx equals 15 multiply between two bracket 5x minus a all to the power 2. What is the second derivative? d2y dx squared. 15 multiply 2 multiply 5, which equals 150, multiply 5x minus a all to the power 1. At x equals 4, d2y dx squared equals 0. Then 150 multiply 5 times 4 minus a equals 0. Then 20 minus a equals 0 and a equals 20. Then the curve of the function y equals 5x minus a all to the power 3 plus 2 has an inflection point at x equals 4. Then the constant a must be equals 20. Now we can choose letter A. Another example. If the slope of the tangent to a curve at any point xy lying on it is equals 5 minus 2 sec power 2 2x. Which of the following is the equation of the curve, knowing that the curve passes through the point pi over 8 and 5 pi over 8? The equation of the curve y equals 5x minus 2 tan 2x minus 1, y equals 5x minus tan 2x plus 1, y equals 5x plus tan 2x plus 1, or y equals 5x minus 2 tan 2x plus 1. We have the slope of the function, or the slope of the tangent to the function 5 minus 2 sec power 2 to x. Then dy dx equals 5 minus 2 sec power 2 to x. Now we can integrate both sides with respect to the variable x. Then integral dy dx equals integral 5 minus 2 sec power 2 2x dx. The integration of dy dx with respect to x equals y. Then the left hand side equals y. The integration of the constant 5 equals 5x, and the integration of 2 sec power 2, 2x equals tan 2x, and 2 divided 2 equals 1 plus constant c. What is the value of the constant c in this relation? We know that the curve passes through the point pi over 8 and 5 pi over 8. Then we can substitute about y equals 5 pi over 8 and x equals pi over 8. Then 5 pi over 8 equals 5 multiply pi over 8 minus tan 2 multiply pi over 8 plus constant c. We can use our calculators to find the value of c, then c equals 1. Now the curve or the equation of the curve is y equals 5x minus tan 2x plus the constant c, or the value which is value 1, then y equals 5x minus tan 2x plus 1, and we can choose letter B. Another example, limit ln x minus 4 over x minus 5 when x tends to 5 equals e equals 1 equals e to the power 2 or equals negative 1. Now limit x minus 4 over x minus 5 when x tends to 5, we can write this function as limit ln between two bracket 1 plus x minus 5 over x minus 5 when x minus 5 tends to 0. In the numerator, we have 1 plus x minus 5 equals x minus 4. And when x tends to 5, we can write x minus 5 tends to 0. Then this limit equals 1. Because we have a general rule, limit ln 1 plus x over x when x tends to 0 equals 1. Then limit ln 1 plus x minus 5 over x minus 5 when x minus 5 tends to 0 equals 1, and we can choose letter B. Another example, if y equal sine 3 by x and z equal cosine 3 by x, then dy dx equals what? At x equals quarter equals negative 1 equals 0 equals 1 equals 4. The first derivative dy dx equals 3 by cosine 3 by x. The derivative of sine 3 by x equals cosine 3 by x multiply 3 by. And the derivative of z with respect to x, which equals dz dx, equals derivative of cosine 3 by x, which is negative sine 3 by x multiply 3 by. Now we have dy dx and dz dx. What is the derivative dy dz equals dy dx divided dz dx? We can use the parametric differentiation or chain rule. Then dy dz equals 3 by cosine 3 by x over negative 3 by sine 3 by x. Then dy dx equals, we can simplify 3 by from the numerator and 3 by from the denominator, and cosine 3 by x over negative sine 3 by x equals negative cotan 3 by x. At x equals quarter, dy dx equals negative cotan 3 by multiply quarter. Cotan 3 by over 4 equals negative 1, multiply negative 1, then dy dx at x equals quarter equals positive 1. And we can choose letter C. Another example, integration 3x multiply square root of 2x plus 3 dx equals 2 over 3 multiply 1 over 5 multiply between two bracket 2x plus 3 all to the power 5 over 2 minus 2x plus 3 between two bracket all to the power 3 over 2 plus constant c equal letter B 3 over 2 between two bracket 2x plus 3 all to the power 5 over 2 minus 2x plus 3 all to the power 3 over 2 plus constant c. Letter C 3 over 2 2x plus 3 all to the power 5 over 2 minus 1 over 5 multiply between two bracket 2x plus 3 all to the power 3 over 2 plus constant c, or letter D 3 over 2 multiply 1 over 5 times 2x plus 3 all to the power 5 over 2 minus between two bracket 2x plus 3 all to the power 3 over 2 plus constant c. Now we have integration by substitution, and let z equals 2x plus 3, hence x equals half z minus 3 over 2 and dx equals half dz, and the integration of 3 multiply x multiply square root 2x plus 3 dx can be written as half integration 3 multiply half z minus 3 over 2, which is the value of x, multiply square root of z, which equals 2x plus 3, and dx equals half dz. Then we have a new function, half integration 3 multiply half z minus 3 over 2 multiply root z with respect to the variable z. Then we can multiply root z or z to the power half inside the bracket. Then 3 over 4 integration between two brackets z to the power 3 over 2 minus 3 multiply z power half, all with respect to the variable z. Now the integration is very easy, and 3 over 4 multiply the integration of 3 to the power z to the power 3 over 2 equals z to the power 5 over 2 divided 5 over 2, or multiply 2 over 5, minus the integration of the 3z to the power half equals 3z to the power 3 over 2 divided 3 over 2, or 2 multiply z to the power 3 over 2 plus constant c. Now 3 over 2 multiply 1 over 5 multiply z to the power 5 over 2, which equals 2x plus 3 all to the power 5 over 2, minus between two bracket 2x plus 3 multiply 3 over 2 plus constant c, and we can choose letter D for the correct answer. Another example, if f is a continuous even function on the interval closed interval -5 and 5, and the integral of f of x dx from -5 to 5 equals 30, and the integral of f of x dx from 0 to 3 equals 9, then the integral of f of x dx from -5 to -3 equals what? Equals -6, equals 6, equals 21, or equals 39. Now, since f of x is a continuous even function on the closed interval -5 and 5, then the integration of f of x dx from -5 to 5 equals 30 means 2 multiply the integration of f of x dx from 0 to 5, because the function is an even function. Then, by divided both sides by 2, the integration of f of x dx from 0 to 5 equals 15. And we have the integration of f of x dx from 0 to 3 equals 9. Then we can write the integration of f of x dx from 0 to 5 as a sum of two functions, integration of two functions. The first, integration f of x dx from 0 to 3, plus the second, integration f of x dx from 3 to 5. And we have the value of the integration of f of x dx from 0 to 5, which equals 15. And we have the value of the integration of f of x dx from 0 to 3, which equals 9. Then 15 equals 9 plus integration of f of x dx from 3 to 5. 15 minus 9 equals 6. Then the integration of the function f of x dx from 3 to 5 equals 6. Then the integration of the function f of x dx from -5 to -3 equals the integration of the function f of x dx from 3 to 5 equals 6, because the function here is an even function. Then we can choose the letter B, and letter B is the correct answer to this question. And by this example, we come to the end of our program today. Till we meet again, it's goodbye.